Well, hello. Welcome to stream number 12 of my reinvention of the wheel, so to speak, of a web server. Making a web server in C++, basically from scratch, which I would call reinventing the wheel. It's a term people use when someone's making something that's already been made before, just for fun, or just as an exercise, or sometimes even just to make an improvement. But I hold no illusions to that. I'm just making my own web server, mostly for fun. And this is stream number 12 again. I've been working on a component to handle international character sets, what they call Unicode, which is a standard way of expressing different kinds of character sets like Japanese, Chinese, Thai, lots of other things, basically any alphabet in the world. And UTF-8, which is a pretty popular encoding of Unicode. So we've gotten a lot of it done already. We can encode UTF and decode valid UTF-8 using our UTF-8 component. And today I'm going to focus on finishing up that component. All we need to really do that's left is to detect invalid encodings. And I found a nice, I guess, test set that describes a lot of the corner cases and a lot of the things to test, either valid and invalid, and kind of boiling it down to what we need to support. There is something called a continuation byte that is present in the middle of a sequence for a character. So at the beginning, if you find one, it's unexpected. So we need to handle these unexpected continuation bytes. Also breaks in sequences. So if you expect a continuation byte and it's missing, we need to detect that. And then there are overlong sequences. And I'll get into that in a bit. And we need to detect those. And for basically security reasons, we need to not allow them. Security reasons meaning someone could hide, for example, a line break in as an overlong sequence and get it past a parser that's looking for line breaks and then screw things up down the road. So we're going to detect and throw those out. And then there are ranges of illegal code points. We already have code to handle the first category, which is sets of codes which are misinterpreted if you use other Unicode encodings. The other one we need to handle, actually I think we already do, but I need to make sure, is handling codes that are outside Unicode's maximum range. So hopefully we'll get through all that this stream and I'll have some time left over. And using that time, I think, or what I'll use that time for would be to bring in an old component that I wrote before I was streaming called system abstractions. And this component handles a lot of the utility things like networks, or sending and receiving messages, starting subprocesses, other things. It doesn't have any unit tests, and it's using an older style for structure, directory structure. So I'm going to be updating that directory structure and then establishing some unit tests, because I'm trying to follow test-driven development where we have a suite of tests for every component that we write. That test suite is giving us confidence that our code meets the requirements, and if we accidentally break something, hopefully our unit test will tell us early. So let's get started, shall we? Just switching over to our unit tests. So the last tests we wrote are to decode valid sequences. So let's, I think, yeah, when we have one for high and low surrogate halves are invalid. So we don't have one for codes that are out of range, do we? Oh, we do. So we have tests for codes that are out of range. So actually, I don't really, we're done with that part. We really need to focus on these three. So let's make a test for unexpected continuation bytes. And before we do that, there's one thing I noticed when I ran my unit tests before the stream. It looks like I dropped the S at some point in the name of my test suite, and so it ended up making two test suites. Let's fix that right away. I think I want it to be plural tests, so it looks like starting here, I accidentally dropped the S. Since that's really quick to fix, we'll fix that right now. Okay, now it's all in one test suite, so I'm going to go and check that in. Oh, and viewer last time suggested a cool tool called GitHub Desktop, I think it's called. GitHub Desktop. And we can use that as a quick and fast way to check this in. And this is fixed name of test suite for a bunch of tests. Cool. A little bit more graphically pleasing than Git GUI. It doesn't have all the features I want, namely being able to stage individual lines and hunks, which I end up doing a lot if I forget to make commits and I switch from one task to another. But if it's straightforward, clear cut, I'll probably start using that tool more. All right. So let's go establish our test for unexpected continuation bytes, right? Unexpected continuation bytes. And my idea for supporting that would be to take one of these sequences, like the A is not identical to alpha, and simply dropping the continuation byte. So we need one where we're decoding, but decoding from a sequence of bytes so we can easily drop it. Let's look. Okay, here's the sequence of bytes for uppercase A, and then this sequence here is for not identical to, and this sequence I believe is for, I think it actually goes this far. I'm just glancing to see if I got that right. It's 1 byte 1 code. This is going to be, oh, that's 3 codes, right? Let me look at my cheat sheet. Yeah, that's 3. So it's 3 bytes for this code, 2 bytes for that code, and 1 byte for that last code. So we're going to, I think what I'm going to do is take this sequence and remove this continuation byte, which is the second part of the alpha code. That's uppercase alpha. I'll drop that and we'll assert that we get, instead of A not identical to alpha, we should get A not identical to the replacement character, because we'll have corrupted it. I'm just looking for where we have replacement character. I guess we don't have it in the unit tests, but I have it up here. Replacement character. So we expect A not identical to replacement character if we drop this. Not that we're not going to drop the continuation byte. Actually, we're going to drop the initial byte. So this continuation byte will be unexpected. So let's change this test around. So we're going to assert that we get this if we try to decode, decode this sequence. Oh, that's interesting. My IntelliSense is not telling me the right thing. Right, we get back a vector of code points. So we have a conversion for that, right? I have ASCII to Unicode. Okay, maybe I want, for a convenience function at least, something that'll convert a string into Unicode. Oh, wait a minute, no. This is an encoding. We want to check it against the decoding. The decoding is this slightly, right? Let me first take that string and put it here. Then we'll put the expected encoding, decoding, not the Japanese one, this one. And like that. And we need to help out Google tests macro a little bit by giving it the type, I think. What's it saying? More than one instance of decode. Oh, yeah, we need to be explicit here. There we go. Right, okay. That's probably a good enough test. Just any unexpected continuation byte, because we're testing two things. It replaces it with a replacement character, and then it recovers by the very next character being decoded correctly. So let's run that test, and we expect it to fail, which it does. So we expected that sequence, and we got that sequence. Oh, I forgot to update this, right? So we don't expect the actual code. We expect the replacement character, which is, I put it over here. Actually, it passes. I wonder if I already coded this and I forgot. Let's check. Oh. I think it actually ends up in this. No, it shouldn't. So that's one code, right? Let me grab the original. Yeah, so I dropped the beginning character. So it'll encounter this when there are no bytes remaining to decode. Oh, right. So yeah, it is going into this else. So it's falling into the else where it didn't match any of the beginning sequence codes here. Yeah, because 1, 0 doesn't match any of these patterns. And I have a note here because this also is matched in these two rows down. This one here and this one here also don't match. I don't think I agree with my note, actually. I think it's okay if the next character is also a continuation, we just keep spouting out replacement characters. Oh, I forgot to remove my little temporary note there. Oops. Yeah, so I guess sort of accidentally, I already did implement the unexpected continuation bytes because it falls into the same else as the codes that are larger than, what is it, 20 something bits. So that's good. I actually don't have to implement it because I accidentally implemented it before. Let's handle a break in sequence next. So it'll be similar to this break in sequence. Only instead of getting rid of the first byte of that, we're going to get rid of the last one. So here's the original. Here's the alpha character. So if I get rid of the last one, now it's going to expect a continuation character and not see it. We'll expect the same output. Right, so what we get instead is a strange character, 942, instead of getting a continuation character followed by a 46, which is a period. So let's fix the code. So in the case where there's a break in the sequence is if it is started if the num bytes remaining to decode is not 0, so it's in this else. So we can see it's going to fail because we didn't actually check to make sure that it is a continuation character. So let's do that. So we'll put a check there, and only if it passes the check will we go to the real else, which is to push it in. So the check is going to be if the octet, and we'll mask out the upper bits. I mean the lower bits. So that would be 3F. It needs to equal 80. That's a continuation character, right? And invert that logic so it's not a if it's not a continuation character, now it's a break in sequence. So we need to do two things. We're going to push back the replacement character, and we're also going to reset the number of bytes remaining to decode. And also we need to actually interpret that octet as the part of the next sequence. So I'm going to do a little bit of a trick here. I'm going to get back out. I'm basically going to make a recursive call. So next code point equals decode. And then we'll just have an encoding which is just the one octet. Right? And then we can append that onto our output. So output dot, there's no append. It's like insert, right? Output dot end, and then next code points begin and end. If we don't do this, we'll accidentally drop the dot or period that came after the alpha. Ooh, and I completely broke it. So is that the right mask? Let me look back at the key. Continuation, it's 80. Okay, I don't really understand why my test broke. Might be one of those days, you know. So let's take one of the cases that broke. 86. Okay, it's the one where we expected. I think it's the very first test case. So let's see what went wrong there. And I'm going to make sure we're running the right test suite. It's UTF-8 tests. Set that as the start project. Make sure it's going to run all the tests. Okay. Okay, that took a lot longer than I thought it would take. All right. So the encoding is those 4 bytes there. So it's going to be basically a 4-byte code, or three more bytes. Take the first octet out. And here's where it should test that next byte, and it'd probably be nicer to look at in hex. A3. A3. Oh, I masked off the wrong bits. It's the inverse of that. E0. No, not E0. C0. It's possible when you're thinking about masks that you get the bits inverted. That's my excuse. Okay, now our test pass. Great. And I don't need those breakpoints anymore. Okay, so we're able to decode breaks in sequences. So let's do the final one, which was overlong sequences. Okay, here's where I'm going to pull in the test vector thing. So I have that in web browser here, and when they talk about overlong, they have a bunch of examples. So here are all the ones that are overlong. So let's just pull all of those in. What's the best way to pull them all in? Probably just individually, right? As a test kind of like this one. decode overlong sequences. Or not decode, really, it's reject. And then encoding, and for all of them, we're going to expect replacement, nothing but replacement characters out, right? So yeah, on all these, it should just yield one replacement character. I'm running Firefox, and it's actually making each character a replacement character, but the comments up here say something like, where is it? I thought at one point it says it should be a single replacement character. Anyway, that's what I think we should expect. We only have one thing in this structure, so we can just place it here directly. And let's just copy these. Copy these right in here. Oh, not string. Vector of view and 8. Next is this one. I don't know if I want to pull in all of these. Don't want it to be a don't want to keep going doing silly things like this, copy pasting and reformatting. We'll just start with 3, and those are what? Those are just examples of the same character slash, and they have corner case tests too. Let's pull in let's say we'll pull in 3 of each. Okay, yeah, I'm pulling in 3 examples of overly long, but just barely. So these are what are called corner cases. They're right at the corner between overly long and not. Let me mark those. These are what? One less than the minimum code point value that should require this many encoded bytes. So this is 7F, so it should just take 1 byte. This is 7FFF, I think? 7FF and 7FFF. Should be 1 byte. And etc. 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 This one's FFF should be 3 bytes. Right? Okay. And these all are all U plus 2F, or the slash character. Should only need 1 byte. Okay, and they have, okay, I think this is a little bit excessive. We don't need that. So this is probably a good suite. So for every test vector and test vectors, we're going to expect that it decodes to the replacement character, right? Do I already have that? No. We'll just put it in here. Replacement character. Oh, it needs it. Yeah, it needs me to give it the type again. This guy. Class type. Oh, that. We don't need that. Oh. Oh, it's a vector vectors. Don't know why I didn't see that before. Okay. So these should all fail, right? Because we right now don't have a overly long sequence check. So we expected a replacement character, but we got 47, which is, I think, is the 2F in decimal. So let's add the check. So the overly long sequences are going to be in the decode, where we have in this section here. And it's right before pushing it back, we should do the check to see if the code took as many bytes as it should have. Which means we're going to have to keep track of how many bytes total we actually shifted out. So let's do that. We have bytes remaining to decode. We'll have bytes total to decode current character. This is the number of input bytes total that make up current character being decoded. It's not until we actually get all those bytes can we see what the value is and whether or not it's in range of what, overly long or not. So let's see. So wherever we set this number of bytes to decode, so we'll set it there. And I guess to be correct, it should be +1 to count the one that started it all off, because so it's going to be either 2, 3, or 4. So yeah, right before pushing it back, we got to do the check. So if current character decode is less than, here's where I got to consult my ranges, right? Less than 80. And bytes total is 2. There's basically going to be 4 cases, right? So repeat that 2 more times with ORs. So it's 800. And the final one is 10,000. I'm going to put that OR in the wrong place. So we're going to replace it if it's overly long, which is this else, right? This makes me think, since there are multiple paths to this, we should have an example of each. Oh, how many of those examples did I put in? Oh, I need to have that case 2, don't I? Oh, I do. Actually, this should be greater than or equal to, because we could have even longer. So we should pull in the one for 4 bytes, I think. Oh, not that one, this one. Although that's not even valid Unicode, so... Oh no, it is. These are all what? Those are the edge cases. I want one of these. The slash case. Actually, they're all very similar, right? Except for it's F8 and an extra 80. There's 5 bytes long. Okay, that's probably good enough. Because I could do the next one for this set, but the problem is it's going to be illegal anyway, because that code is bad for another reason. It's outside the Unicode range completely. So let's check. Let's check if it works now. Didn't work. Broke something earlier. So let's see. I probably have some kind of logic issue that I might be able to see by eye. Right, so if it's and less than that. Oh, I had this backwards. Yeah, logic inversion. That's the most common bug that I introduced by accident. Okay, for one of our test vectors, we got out 5 replacement characters instead of just 1. So which one was that? That's 131. Let's push out the index of the test so we can see which one failed. Ooh, it totally crashed. Probably because I didn't initialize that. Yeah, so index 3, 0, 1, 2, 3. Did I not copy that correctly? Probably. F8, 80, 80, 80, AF. Oh, is it because this is a 5-byte sequence and we just don't even handle those? Probably. Yeah, so those are automatically rejected as the F8 is automatically rejected right away. Okie doke. So remove that test vector and we're passing again. So I think what that means is we're done with all of these different invalid encodings, which means we should be done. I'm wondering though if we should pull in the other test vectors that they have in this nice list of examples. Circuits we already have a good test for. I'm not going to check for these because they're just problematic and not illegal. Impossible bytes. We could check for those. Right, ones where the last byte is missing. We did those. Lonely start characters is the same as what are we calling it? A break in sequence. Yeah, I think there's nothing in there that indicates we're missing any kind of test. I could beef it up just by going in and adding more cases here, or maybe more cases in these two places. But looking at this check, I mean, I think it's simple enough. We don't really need to be elaborate. So I'm going to call it done. So let's just check that in. Oh, not this one. Even though I could use GitHub Desktop for this, I'm just going to fall back to Git GUI because I'm still a little bit more comfortable with it. Oh, by the way, I found this bug this morning in, I think, the Electron framework. You go to VS Code and you look at this test vector. I noticed that the slash was over the A instead of over the triple horizontal bar. That looks like it's a bug in Electron because you can see the same problem on Windows desktop with Discord, which uses Electron also. And you can kind of see it here where the slash got over the replacement character, not where it should be. So I actually filed a bug this morning for the Electron framework for that. I tried filing bugs for VS Code and Discord, but the Discord folks said it's not our bug, it's in Electron. So I'm like, okay, fine. File it in Electron. Yeah, you can see it there also. Anyway, just thought that was random. Git GUI doesn't have the problem, and Visual Studio itself does not. Most likely because they don't use the Electron framework. I'm actually curious now if GitHub Desktop shows the same bug. Yeah, you can see the same bug, and GitHub Desktop also uses Electron, so they all have the same problem. Anyway, this change was all about detect different kinds of invalid UTF-8 encoding sequences. Replace all invalid sequences with replacement character. In a lot of cases, it'll be a single replacement character, but in others, like if the first byte is missing, you'll get a replacement character for all the other bytes after until you get the correct start byte again. And I think the spec says that that's fine. So before we move on to the next component, I'm just going to glance through our UTF-8 implementation and see if there might be some places where I could clean it up a little bit. Oh, one thing we didn't test is calling decode in 2 steps. We should have a test for that. So let's say we have this character for stump of tree, Chinese ideogram, and it spans 4 bytes, right? So I wanted to allow you to call this in 2 steps. So we'll call this is the first part of encoding, and then or first half and last half of encoding. So we're going to just remove those 2 bytes there and remove these. I wanted it to be able to handle that correctly. So 2 asserts, right? And we're going to call it twice. First, we're going to assert we get nothing on the first call. We'll decode the first half. But when we decode the second half, we're going to expect that we get that code out, which is this Chinese character, stump of tree. Stump of tree decoded in 2 parts. That should already work, but I wanted to put a test in there to make sure. And I'm going to rename the original test I stole that from and call it stump of tree encoding, as opposed to decoding in 2 parts. And let's just make sure that that passes, and let me break. I like to break the unit test. If the unit test, I'd never see it fail at all. I like to break it to see it fail at least once to make sure that I didn't. What are the things I could do wrong? Somehow test doesn't get picked up right, or it's passing for some reason, like you could return early. For example, let me show you how that would, one way to do that. If it should have failed, right, but I return here, I get no compiler warning or anything, and the test passes, right? So I don't really know that the test really tested anything until I see it fail at least once, right? See it fail, and then see it pass. Then I'll be fairly confident that I know why it passed. It passed for the right reason. Let me check that in. So add, well, let's check this in 2 pieces. And here's something that I wouldn't be able to do with GitHub Desktop, because I want to just check in that changed by itself. Oh, refresh maybe. Patch doesn't apply. Don't fail me now, Git GUI. What if I stage hunk? No, it doesn't like that? All right, I'll stage the other one. We'll do the other one first, whatever. Still GitHub desktop wouldn't be able to do this at all, but this is to make 2 commits out of changes in your workspace. Add test for decoding a multi-byte sequence in pieces. So a case where you end up needing this in the real world would be if a message is fragmented and you're feeding the message to the UTF-8 decoder whenever you get each piece. You'll get a piece that maybe ends in half a character. You don't want to throw that away. But when you decode the part that follows, you want it to complete the beginning. You want it to complete the character that it got halfway through decoding previously, right? So it's a useful thing to have. Okay, now this one was just rename stump of tree to stump of tree encoding, and this is just to make it stand out from the other stump of tree test, which was for the decoding. Okay, so what else can we maybe clean up, or did we miss any tests for? This could be consolidated a little bit just by counting the number of 1 bits. But actually, it's only 3 possibilities. I'm inclined to keep it the way it is. Same thing on this one too. Yeah, I think this class is small enough and to the point enough that we can just leave it the way it is and we can move on. Right. Here's something that we would relocate to a generic utility library at some point. Or maybe we just keep it here. And everything inside this anonymous namespace is just private stuff used by this file only. So it's fine to leave it where it is. Where we might want to promote this, something like this, up to a utility library is where we use it for more than one place. So I'm going to call it for UTF-8, and we'll now move on to the next thing. First, I want to make sure my workspace is completely clean. I'm going to use the tool I wrote called Mugget and ask it for status. Oh, I already know what's going to tell me I have an untracked file en route. I was working on setting up the license file for my repositories so that I could put it up on somewhere public for you guys to clone and play around with. And in order to do that, I need to set up the license file. So I was in the middle of that and haven't finished that. I'll be finishing that later. It should just be that license file. Looks like I have 4. That means they're unpushed. So let's push those. Push them upstream. So now we should be relatively clean. And I can clone in the legacy component that we're going to work on next. And that's called system abstractions. So git clone get bitbucket org, right? System abstractions. They didn't spell it right. Here we go. So all I need to do to pull it in, and I'll show you how it gets kind of incorporated into the workspace. At the very top level, it's in the SeeMake, and it's also in this manifest, right? So if I ask Mugget to add it, system abstractions, it's going to add it here to the manifest, and it also adds it to the git ignore up here. What the tool doesn't really know how to do is update the SeeMake. And that I have this list down here where I add the subdirectories for each subcomponent. Okay, so now it should build, and I should be able to commit this so that I can track it in version control. If I build in Visual Studio, it detects the change in SeeMake and rerun SeeMake, and then it'll ask me to reload the solution file, and I should see the system abstractions throw up. Here it is. So part of the work that we're going to do, we're going to restructure the files in that directory, and we're also going to add tests because I don't have any tests for systems abstractions. So this is what's known as handling legacy code, either code that you wrote in the past that is in a different style and need to freshen up, or code that someone else wrote, or it could be code that's ancient that you public domain or whatnot, and you need to make it conform to whatever standards you have. It's called handling legacy code. People actually write books about it and everything. So we're going to do a bit of that because this, I'll show you briefly what it has. This library's got a lot of stuff we're going to find handy in the future. So I'm going to want a whole system for gathering what they call logs or diagnostics. So I have a whole bunch of classes for establishing a context, sending and receiving diagnostic messages, reporting them to streams. So we're going to find that useful. I have a directory monitor, which is really handy for a program checking to see if there are changes made in a directory. We'll use that in our web server in order to trigger module loading and unloading and reloading for plugins. Dynamic library, which is how we're going to load plugins. And then I have a bunch of classes for handling files or file-like objects. That's iFile is the abstract interface. File is an actual file system file. Yeah, same thing for collections of files like directories and such. I have a string or buffer-based file, kind of like string buff in C++. String extensions has something I really like to have, which is a form of string of sprintf that goes to a C++ string, so you don't need to pre-allocate a buffer. And there's subprocess for starting child processes, target info for getting what kind of architecture you're running on, and time is also nice to get. And I named this whole thing system abstractions because a lot of these things are different from one operating system to another. And I wanted classes that abstract all the differences away. So a lot of the differences are hidden away in these subdirectories. So for example, Win32, Windows has its own way of dealing with subprocesses and network connections and endpoints, file system, right? And it's going to be completely different from POSIX or POSIX, however you say it. And then Linux and Mach, which is the base, a kernel for iOS and not iOS, but Mac OS, have a few things that are different as well. So this library has all the files in its root folder, and recently I've switched my style over to this approach where we separate the headers from the source and tests are in their own directory. So we're going to be restructuring system abstractions to follow that. That's probably the easiest thing we could do, so we can start with that. So let's establish a new directory here. Include. Under include, we'll make system abstractions. And then why do I repeat the name? Because the names have different contexts. The name at the top, the context of that is to build the thing, system abstractions. Context at this level is including the thing from other things. So if an app includes system abstractions, it finds system abstractions by having the include the parent folder in the include path, so that if say #include system abstractions / something, it'll find it, right? Whereas this directory up here, it's only used when we're building system abstractions itself. It could actually be named anything in the end, as long as what we build is named, it ends up being installed or named system abstractions, right? So that's why we have it twice. In this directory, we're going to put all of the API headers, which I think is going to be all of the headers. And let's just move them all in one fell shot. All of these headers. All right, we're going to move them all. Oh, there's one more. Move them all under system abstractions. Okay, and then we're going to establish, oh, wrong button. We're going to establish a source directory. Under there, we're going to put all of the CPP files. Oh, I missed a header file. Okay. And there's the header file I missed. Okay. Now these target specific folders I believe they're all implementations, so I think they all get ganged under source. So for the implementation, we'll have these, and these include HPP files, but those are internal HPP files. They're only included by other implementation files. We don't need a git ignore anymore because this dates back to before I used SeeMake. So we're going to delete it. And I think SeeMake Lists, we just need to do two things. I used to use glob, file glob, to automatically build the list of sources, but I've read that there are downsides to this. Namely that if you were to add a CPP file, SeeMake doesn't automatically know that it needs to be rerun because this glob is computed when you run SeeMake and not before. So it's better to actually, whenever you add a CPP file, to add it to a list explicitly in your SeeMake list so that SeeMake knows that your SeeMake file is updated and it needs to rerun itself to discover the new file. So we're not going to be doing any of this glob stuff. And this target folders, yeah, we want to keep that. We don't need the source extensions anymore, I think, because that's only used by the globs. Right? Well, that's the glob stuff. So yeah, so we're just going to, actually I'm going to compare that with one of our other SeeMake files. And let me see, I can do this as a split. View, split. Where's split? It's here somewhere. Is it file? Is it editor layout? There we go. Split right. Okay, there we go. So it's just following the same format. Set this system abstractions. Really, I want to compare. I don't want to look at this unit test. I want to look at the component itself. We don't need to set the standard really because the parent directory does that. Oh, and I want the copyright in the header, all that. Just trying to make it look like the others. I wonder why I had that twice. I guess I must have did a copy paste and didn't notice. Set headers, and we'll have a set sources, and then we're gonna have a list append. Because instead of the set target folders, right? We don't really need that. That was used in the glob. So instead, it's going to be an append. Is it append or is it list append? I can't remember. Let's look at the manual. I like to use this offline manual collection. For Windows, it's called Velocity, and for Mac, it's called Dash. Maybe it's list append. Let's see if that's right. Oh, it's list append. Right. List append, and then the name of the list, sources. So let's get our list of headers here, right? It's going to be include. Yeah, I'm going to repeat the name. System abstractions clipboard. But we can put that in our clipboard, no pun intended, to avoid typing it again. It's a little bit tedious, but we only have to do this once. Library. Whoops. Oh, I already did that one. I lost my place. ifile.hpp. ifile collection.hpp. Network connection. Oh, hi, Natzane. How are you doing? Wildcard debt. Yeah, I was just talking about before how I used to use glob, but I was convinced by one thing I read about the fact that glob, it works if you know that you need to run CMake, but if you change a file or you remove a file and you forget to run CMake again, the glob only helps you if it already knows it has to run CMake. I'm doing pretty good. It's really hot here though. How are you doing? So, and I also justify not using globs here by saying I only have to type this once. If I add something, I only have to type the thing I'm adding once. Bear with me, this should only take a little bit longer. Yeah, I could find the reference to that not recommendation. I think it's in the SeeMake manual itself. Trying to wrap your head about web dev. So what are you doing with web dev? Is it something like Angular or React or what's the other one? Can't remember the third one. One of those popular platforms? Because I'm hoping to get to React development at some point. Oh, Vue, yeah, that's right. I want to start doing some of that stuff at some point. Probably when I have the web server going, we'll make some React-based web clients, and only because I've been using React at work, and so I'm a little bit biased towards it. But maybe when I get into that, I can learn something from you, or vice versa. So sources, it's all going to, yeah. So we have our generic sources. Yeah, it's a bit of a change, right? Going from C++ to web dev. And I think in the past the languages are a lot closer, but now these frameworks like Vue and Angular and React, they're a lot different than what do you call C and C++? Imperative programming. A lot more functional programming. Whoops. VS Code is trying to be helpful by auto-completing this stuff, and I don't want it to. Okay, source. Okay, that should do it for OS independent headers and sources. Now we have to be specific for each OS. So for Windows, we're pulling in these specific files. Source Win32, clipboard Win32. And this part's going to be the same for everything in the list. File Win32.cpv. I hope you're using something like in React, there's create React app. I don't know what Vue has, but I found that really convenient for getting off the ground. They basically set you up a working web app right away, and then you can just play around with it. You don't have to like figure out how to set it up in the first place. Okay, almost done. Maybe I'll save the gory details about Linux for later, and Mach and all that stuff. We'll stop while we're ahead at this point. So we're gonna have to eventually do the same thing for Apple and Unix and all that, but for now we'll just leave it how it is, and we'll flip over to Visual Studio. And okay, I must have mistyped something. Nor sources given for target. Oh, really? Did I misspell sources? Set sources, sources. It thinks I didn't give any sources. But I did. Did I misspell something? Don't see anything obviously wrong. Add library this static sources headers. Oh, that's the, oh, this, I need to fix this anyway while I'm here. We don't have a test subdirectory yet. So what did it not like? Oh, okay. I didn't have a misspelling. Stream reporter is misspelled. I don't need this panel anymore. There we go. A little bit of dyslexia. All right, so SeeMake's done. We have to fix up all of our includes though. Okay, how come? Oh, maybe that's just because we didn't reload the solution. Yeah, maybe. Yeah, okay. So because the source files and header files are in different folders now, we have to be explicit about including them. Why is it wanting to delete the rest of the line? Hate that. VS Visual Studio, you're not helping. Okay, I'm going to in general going to want to do that thing wherever I see one of these guys. So you can tell it's legacy code because I have copyrights dating back to 2013. So you learn a lot even in 5 years. And one thing I've learned is I should have been making unit tests from the beginning. This whole library doesn't have any unit tests, so we're going to try to fix that problem. Okay, yeah. That's just that. Yeah, all of these relative path includes are not good when you're including public APIs. Only private APIs should really be included with relative paths. Public includes should always be like this. That goes there. How long have I been programming professionally? Since 1994. I've been at the same company for 24 years. But kind of transitioning out of that job now. It is one of the reasons why I'm kind of trying out streaming. Because you can't stream at all from a professional job. But if I'm just doing hobby stuff, I can stream to my heart's content, right? All right. Yeah, so if I were to look back at the code I wrote when I was an intern at my current job back in 1994, I'd probably be all cringy. I didn't write that, I swear. I might sound young, but I wish I was 30. I am not. I'm a bit older. Maybe it's the mic. This mic makes me sound young, maybe. Okay, so everything builds. Unfortunately, I have no unit tests. But minimally, we can check this in and say we at least restructured the project. Okay. Let's use the nice one that a nice viewer yesterday told me about, GitHub Desktop. I just need to tell it about our new repository. Projects, Caliber, System Abstractions. And I can just simply say restructure project commit. Alrighty. I haven't seen enough streamers to know what the general ages are for the different streamers. The ones I've been following, though, they're younger than me. So I started thinking maybe this is a millennial thing, and I'm like an old fogey. Let's see. What are we going to do to set up unit tests for this thingy? Maybe start with something simple, or we need to actually establish the unit test project itself. So it'll be next to include and source, right? Under system abstractions test. Under test source, and then we'll need a SeeMake lists.txt. And we can start by just shamelessly stealing one from another project. Streams you follow are mostly low-level systems programming streams. Oh yeah, I was just about to ask what would you'd recommend. I've only found a few programming streams. You know, I browsed them, but I haven't really found any that I like. So NibbleCO? Okay. Hope you guys don't mind. I will temporarily take a note for that. Check out. Just so I don't forget. Currently making its own language in C++. That's cool. Let me write down your next suggestion. So I did write my own language in C++ too, but I also used Bison and Flex. And I maybe I'll show that on a future stream. I made my own language to describe file formats so that I could make a tool to parse generic files. And found it really useful at work using it for parsing media files like MP4. I'll have to show that sometime. So I'll have to check out his stream to see if he's doing it just in C++ or if he's leveraging a parser generator like Flex or Bison, which is what I do. Okay, so we are going to take UTF-8 and just steal its name. System abstractions tests. And that's good enough for now. We just need to make a file. System abstractions. Actually, we're going to, because system abstractions is more of a collection of classes, we'll make one per class. And the one I want to start with is one of my favorites, which is string extensions. I'm just going to hit rename, copy, go back to that and paste here. So far entirely in C++. Planning on remaking the compiler's own language. Oh, that's awesome. Yeah, I'll show it. I don't have a good name for it. The best I could come up with was data disintegrator, because you basically pass in a file you want to like break apart or parse, and you can think of the file as an integration of pieces, and you're picking it apart to look at the pieces. There's probably a better name, but right now it's data disintegrator. Okay. I was just thinking, could I show it quickly now? I don't know if it's running. Let me check off stream, and if it is running, I'll show it next stream. Let me make a note for that. I keep closing my OneNote. So next time, show and tell data disintegrator. I will try to remember to do that. Yeah, doesn't it? It does sound like a laser aimed at satellite. Okay, so string extensions tests. I'm going to steal some of the boilerplate from from this guy. Actually, we'll steal the entire file to start with. String extensions tests. And it's really unit test for the system abstractions. What am I calling string extensions? Functions which extend the string library. Okay, we'll just copy that. Contains unit tests of the systems abstractions functions which extend the string library. Okay. So what we're really including is system abstractions. String extensions. Kind of a long name, but oh, why do I have tests? I didn't see that. Oops. Fighting with my editor. Left, right. Okay. Just delete those characters. Yeah, so one of the things that you can do is sprintf, like in the C library, but you don't need to give it a buffer. It just returns a C++ string, so I kind of like it. So sprint. Can I just leave it lowercase? It's probably fine. It's not capitalized, but that's fine. So just thinking, how would I say? I would assert true that hello world is equal to say safe. It's system abstractions. sprintf, and then I'll just do s comma s hello and world. It basically supports everything sprintf does. So all we really need to test is that it returned a C++ string and it did something that we might expect the normal sprintf to do. And oh, there was one thing I needed to do in the main SeeMake, which was add direct subdirectory? Tests. I can't remember the syntax, so I'm going to look back at this one. It's just test. Okay, test. And then the test itself, did I put an add test? I did. All right, so good. Rebuild in Visual Studio will rerun SeeMake, picking up our tests. Right there. Now we can build. It should have actually built them too. Well, sometimes it does, sometimes it doesn't. It didn't that time, so. Now I'm going to run ctest to see if it makes it up overall, and it does. So I can just do this. When you get into the hang of it, SeeMake is kind of nice. I added that component in pretty seamlessly. Let's check that all in. Did anything here? I did, besides the license file. Oh, I forgot to check this in. That is essentially add system abstractions project. Oh, hi, Calidora. That looks familiar. I think I might know you. Your question, if you have RTTI enabled, you should check that the return is a standard string. Would you agree? Check that the return is a standard string. Good question. So I think I know what you're referring to. I have too many windows open. Close all these guys. Yeah, so IntelliSense tells me it's standard string, but I don't have RTTI enabled. And do I really care? Because the contract really is just I return something that's equatable to a string. I guess I can do this. I can say const standard string expected output, and then we'll actually combine this with another test. The answer is 42, right? And now we'll expect that it's at least comparable to a standard string. That way, I really want to avoid requiring RTTI to be enabled, because you might want to use my library with it not enabled. So the answer is D. We just need to make sure it's an int. Thank you for the suggestion, by the way. Let's make that another test, because why not, right? And we'll say, for this one, sprintf behaves like the standard C library, right? Standard C libraries version. And this one is more that sprintf returns something comparable to CPP string. RTTI and exceptions will prove valuable as you head towards dependency injection. One of my early streams, I gave a little bit of explanation about why I'm adverse to exceptions. So I've been trying to avoid exceptions probably because I'm biased against them. In the early days, right, you couldn't enable them on embedded targets. So what's really ingrained into my APIs, if you look, for example, at UTF-8, we just worked on that. The method to decode, okay, that's not a good example, not UTF-8. How about URI? The method to decode a URI or parse a URI, right? Where is it? Here. This is what I've been doing to avoid exceptions. Instead of returning nothing, I return a flag indicating if it was successful or not. And if you wanted more information, I have two techniques. Either you can call another method of the class to ask it for the last error, which is something Microsoft likes to do. And the other alternative would be to enable diagnostics and get the error back out of a diagnostic stream. I mean, you'd probably think it's not as good as exceptions, and I have no real good justification. My excuse for now is that I am so biased against exceptions, I'm still avoiding them. But maybe you can convince me to be more friendly to exceptions. And maybe the same thing about RTTI. I really haven't used RTTI enough to feel comfortable with it. And for anyone else who's looking, RTTI stands for Runtime Type Information. And I'm going to do the good thing, since I don't think I have it in the name section. Initialisms, right? RTTI. This is something I hope Calidora appreciates. So runtime type information. This OneNote notebook, you can view, it's public. There's a link below. I at least spell out, if not give a link to every initialism, acronym, term that I use, a project-specific name if I invent one, and then the major design principles I try to follow, and then design patterns of various kinds. I was going to add strategy pattern here, and I forgot. Let me make a note to do that. Remember to add strategy pattern to the pattern list. I'm just reading your comment, Calidora. Okay. I'll have to consider your words. I'll look back at this later and consider it. I don't want to get too, what do you say, sidetracked? So I'll put that off for a little bit later if that's okay. I wanted to make sure that we established a decent set of unit tests for at least this module. So let's look back at that module. I don't think there was much to string extensions. Okay, I had a variant for if you have a, what do you call that? Variable argument list. And then I had a convenience function for going to a wide character string to a multi-byte string. Okay, and I do have some other ones. So we need to make tests for all these guys. At least one, right? Thanks, Caladora. We'll have to chat later. I'm interested to see if you've been watching before and just lurking, or if you just found this. This is like my 12th stream. Okay, sprintf. So this one takes a variable argument list. So it's kind of like the other one, only we're going to need a VA list. I think we need a helper for that, right? So something like this. VSprintf helper. And it's going to take the same kind of thing. I think I can just repeat my test from down here, right? And just be lazy about it. I just want to call the helper with the VA args. Oh, which is this, right? And, okay, I need to consult my manual again, because I don't remember. Lots of things I don't stick in my head, because I have it, I know it, I have it in the manual, right? Okay. Oh, hi there, I built Aris. Would you mind if I asked you a question? Sure, no problem. Been stuck on a stupid issue for over an hour now. Sure, go fire ahead with the question. While I look up VA args, which I don't remember where they're defined. No problem. I'm still looking for VA args at the time. Okay, my manual's not helping me out here. Oh, VA list, that's why I'm not looking up the right thing. It's still not helping me. Why not? VA list. Okay, it failed. Let me try my backup, which should be Google. Oh, I really don't like C++.com. CPP reference is nicer. Okay. This is what I wanted. I just wanted to, it's VA list. Args, and then you have to do a VA start. And count. Oh, count is just the first argument, right? So that. And then you can just pass in the args. All right. And as long as you do a VA end args. And then I have to return the result. The result is here. Sure. Show me the code. Do you have a link to it? I can we can bring the whole community to look at it for a second. Basically took an input file and separated it into two different arrays. However, when you print the first index of the second array outside the loop that reads the file into the array, outputs the value for both 0 and first index. Okay, yeah, let's look at your code if you have it in pastebin. Meanwhile, I think that will test my VSprintf. Yeah, we can turn this into a live debugging session. We'll see if people like that or not. You can give me the feedback. Okay, good. Our VSprintf test is passing on. I guess I didn't run this other test Caladora suggested earlier. And my general rule is if the test passes right away, I break it. Just to make sure that it's succeeding for the right reason. Okay, so yeah, I can break the test. So it's passing for the right reason. And let me do the same thing with this guy. Okay. The tests are passing for the right reason. So let me check that in. Still waiting for the basebin link, by the way, but no hurt, no rush. Right. Yeah, this was mostly to establish the unit tests, right? Establish unit tests. So this is the first time we actually started with legacy code, and all the other projects we've done so far in the stream have been pure test-driven development, where we start with tests and then write the code. This just happens to be code I've written years ago and I'm wanting to include in our project, which is why we start with the code and we're dealing with the legacy code by writing test framework for it first. So we want to have a test for a wide character to multi-byte string. Okay, this one takes a wide character string and returns the multi-byte equivalent. So this is actually very similar to what we were doing earlier in the stream, which was Unicode decoding and coding, right? I'm wondering if I could leverage any of the test cases we had for that. The problem is, how do we specify a wide character string? Is it as easy as just saying L and then characters? So we can just say hello world. We don't have to use international characters, right? So assert equals hello world. It's equal to system abstractions WCS to MVCS. I just can't remember if that L is just for Microsoft or it's part of C++ or C. Okay, I see this basebin link. Let me just make sure this test works first, so we'll switch over to that. And I need to break my test. Okay, yep. Okay, let me just check that in. Then we'll get to the live debugging session. Okay, let the live debugging session commence. Okay, main. Okay. I could ignore the unused structures at the beginning. Okay. And you print each line as the second for loop runs. Yeah, there's no issue. But when you run that printf statement after I exit the loop, it outputs the value for data items 0 and 1. Let's look at these loops. So you mean this is what you mean by second loop? Line is what? Oh, it's a buffer. 21 elements of 100 characters each. Well, I can't remember. Does fget_s store the end of string marker? The 0? Is this one of those things you can... No. Oh, I see. You're saying it prints out two values. Well, you don't have you're not printing out an end of string here. I wonder if that's, wonder what happens if you were to add a /n here. It shouldn't print the values for 0 and 1 though. That doesn't make sense. It's just printing one of them. Is this a complete program we can play with? Yeah, it is. In fact, you have the raw paste data here. How would I do a quick addition here? This is going to be temporary. We'll just put your program in here, right? And we're just going to change it to, we don't need, just temporarily. We don't need all this stuff here. Oh, we'll need your file though. That's easy enough, right? Since I'm just reading, I shouldn't speak until I'm done reading. Does the property null terminate? Yeah, that's what I was wondering. Does fgetS actually, let's look it up, right? fgetS. The produced Y string is always null terminated. Oh, why did it look at that? It writes a null character at the position immediately after the last character, so it should null terminate it. But what does your input file look like? Does it, here, I'll show you an example in VS Code. So from your raw data here, from here, does it look like that or does it look like that? It looks like that. Then your last line's not terminated right. If you have it like that, that's what you want. And I need to look at your loop again. Okay, you terminate when fgetS returns null. So when does that happen? Stops if an end of file occurs or a new line character is found. If no error occurs, writes a null character. It's only going to return null on failure. What does failure mean? Is that when it has already hit the end of file? So you're probably doing the right thing at the last. Yeah, if you did this way, you'll have an extra line with no number in it. What happens when that occurs? But you have a check for it. And you break it. That's probably, you probably ran into that, right? If you have something like that, then the last line is going to be blank. Or also you have this intermediate line you're going to break out. Oh, this break is to break on line 6, right? And this one's just supposed to read in 2 numbers. Oh, you're not actually reading from a file, are you? You're reading from standard input. Did this get squashed together? Those two last lines get squashed together somehow? That's what I'm wondering. Hmm. I'm thinking something like it could be. No, no, that's not right. Okay, I don't know. I don't know why it's combining the last two lines. Yeah, we can try it. So the problem is I need to put it in a file. This stuff I don't need, right? Well, actually, it's going to read from standard input, right? When we run the program, it's just gonna ask me for those numbers. What did it want a declaration for? Oh, yeah, it's some extra gunk. Let's run that guy. Okay, once that's standard input. Does it really matter what numbers I put in? Yeah, here's the problem. How do I terminate? I think it's Control Z in Windows. Yeah. Oh yeah, it did print out the 25. Why is it doing that? 15, 25, and it printed out that extra 25. What if I do 25 and then end right there? Interesting. It like didn't stop right away. So instead of standard in, let's do a fopen. How does fopen work again? It's going to return the file. File name data. Read text. F goes here and here. And probably we should do the right thing and F close F here. Yeah, when I have test data, there's a couple things I'd like to do. I'd like to have a tool that takes the data and encodes it into a header file, and then I include the header file for my tests. And if it needs to be from a file like that, then at the beginning I'll actually, or in the setup for the test suite, I'll create the file, and then on the teardown I'll delete the file. But this is good enough for now. I just need to make that file, right? I had it in VS Code. Just need to save it, and we're going to save it here. I think I need it here. I need to give it a name. Test.text, I guess. Okay. Ooh. Oops. Is that because that F got in there? Oh. What happened there? Is that because I don't have the right line terminators in there? Let's see what happened. And don't have the right test setup to run. Stream is not valid. It didn't open the file correctly. I'm probably not running it from the expected directory. Working directory project dir? Yeah, that's not right. We want to run it from solution dir. Okay. Okay, so what's line 0? Okay, it's got the line in there. Oh, did I have a space? I did have a space. You don't have a space in your file, right? And this is, okay, this is fighting me. It wants to make that last line a blank line. So I'm going to just go here and do notepad on the thing. Bring notepad over. Okay. C4. Break. So it's gonna, it has 15 new line, but then there's something after that. How come it has a dot, dot, dot? Okay, let me actually view that in the memory. Memory 1. Data mem. Okay, it has the null character there. And it's just a new line. It's not a character turned new line. Okay, the next one is 25, and there's no new line. It's just a null character. I should have the window open that's showing it. Now, when I switch back to here, you won't see it, but that's okay. Data mem 0. I think I see what happened. It we end up with, yeah. See, data mem is you only gave space for 3 characters. So that's not enough to store 1.5 new line null terminator, right? We need 4 characters. Right, so if I do that, I bet it'll work now. This is why I only do so much code inspection. If I don't see the problem right away, I'll just run it in the debugger. There we go, that was it. And maybe that's the lesson here is you have to really be careful about hard coding numbers, especially if there are limits for data. In a real live program, this is going to be a problem, right? Buffer overflow. It can lead to really bad things. So no, you're not an idiot. You'd only be an idiot if you didn't listen to other people's input. So every I think mistake like this is always good because now we all learn something from it, right? So feel free to keep those, what do we call them? Impromptu debugging sessions coming, or questions? What's my Reddit username? I'm actually not on Reddit, but maybe I should be. How about you just follow? That's a good enough reward. Fair enough. Does anything else you want to look at this, or should we go back to coding my stuff? Maybe I'll try to work this into an example of how you'd pull in the test vector. Let's do that. Hope you don't mind me leveraging your code example for a little bit of a explanation. So up till now we've been using just test, but if you were to upgrade this to F, which means you have a framework, then we can do something like this. Actually, we can do it right here. Class viewer code derives from testing. I think it's test framework. test case, I think. And then you get to do really cool things like what I'm going to do, which is there's a setup and a teardown. Just trying to find out what's the name of it. Okay, it's called, here they are. We can override these, right? We can also hide our file. This is teardown. How did that not get copied over right? All right. Do I not have that right? Is it not test case? And I might need to Google this real quick. In other words, my extension to my brain. Okay, Google test case. There's a test fixture. It's just test. Okay. I wonder why. Yeah. Okay, now it's good. So we can put our file in here. And this will make sure that no matter if the test bails early or succeeds all the way through, we can make sure we close, not only close it, but if it was a temporary file, we might delete it here. And then here we can do the open. And it's no longer auto, although my indenting needs to be improved. See, now I don't need to worry about that. How come it doesn't like the F? Oh, I have a missing semicolon there. So this is a more advanced kind of test case. And why did it not like that? Public. That's probably why. You might have to work on my little program, but anyway, sure. Come and go as you like. That's fine. I thought that this would become a member of that. How come that's not working? I guess you have to say protected. All right. So that's one way to, it's a more advanced test, and I'll probably do these later, where I set up what they call test fixture, and you can have the setup that's common for all the tests and all the teardown for all the tests. And that's what this _f means, by the way, fixture. As long as that matches that, the Google test framework provides the rest of it. So this is just a bare bones thing to work with a file so we don't have to worry about opening and closing it. But a more advanced thing might be in the setup, we could create a temporary directory and we could write the test stuff to that file and then reopen it for reading only, and then let our test run, and then close, and then destroy the test file and test directory. So a nice, clean, balanced setup and teardown that can be as advanced as we need it to be. So do we need to keep this around for posterity? No, it's captured in the stream, right? So it'll be captured in the video. We don't need to capture it in our version control. Oh, I need to get rid of the headers I included before. I don't need anymore. Okay. Okay. So I think what I'll do, I need to take a break in a bit. So maybe what we'll do is we'll write unit tests for the rest of this particular module and leave the rest of the modules for after a break. So this is actually a great place where we can move a lot of the other string extensions we ended up writing for URI and UTF-8 and other things. So let's just set out the tests in advance, and we'll write the bodies for them one at a time. So we have trim, indent, parse element. You can see another problem here is I got really lazy and did not document these. So I'm going to have to inspect the code or kind of guess what these functions are for in order to write the test. The test actually, you could say, is the documentation. But I also want a small comma to abbreviate or give it an abbreviated documentation. So this is a split that is like the split string we wrote a few streams ago, only it's kind of simpler. Yeah, self-documenting code, which this probably is. These are pretty simple. So, trim. Actually, we have a comment for it. It removes any white space. Actually, this is the same thing we have elsewhere, right? We wrote this in an earlier stream. So an example for that be something like this. Oh, that should be that. Just absurd combinations of white space, right? I believe that's what it's supposed to do. So we'll see if I'm right. Okay, so let's break it. Okay, yeah. We're good. So that's trim. Self-explanatory. Indent. I'm not so sure, but let's try to guess. Indent. We're going to indent some lines, some number of spaces. So maybe that is self-documenting since it's so simple. So indent. Let's make 3 lines. It returns a string, right? Lines in. I'm guessing it's going to also break the lines up, indent them, and then put the lines back together. Let's see if I'm right. This is line 2. This is line 3. And let's say we're going to indent 2 spaces. I will first copy that, paste that, and then indent this 2 spaces. Too few arguments? What is this? Too few arguments. Really? Oh, I needed to tell it how many spaces. 2. I think that's what the function does. Well, let's see. Okay, it's not what the function does. What does it do? It did not indent the first line. Oh, okay. So it's indenting every line except the first. So that's its behavior. All right. So let's look at the code and make sure we got it. We captured the requirement. Yeah, so okay. It's this condition if makes sure it only does this for the second and subsequent lines. If this if was missing, it would have been what I originally thought indent would do. I think I know what I used this for. I was using this for serializing out data that had structure. So something like this would make more sense. Struct field 1, field 2. Would be what we expect to see if we have struct plus indent these 2 fields by 2. I think that's how I've been using it in the past. And what did it not like? It did not like that there are too many parameters. Oh, because I had a comma there. And maybe to make this visually apparent, I'll do this little trick here. Oh yeah. Interesting. Is it that I used it this way? This might be why. I think that's how I was using it in my structure stuff. Okay, except for there's no character turn at the end. Yeah. So it's a little bit more than just indenting. It's also got some undocumented behavior that we'll probably want to clean up. Anyway, that's capturing the essence of what behavior we expect from indent. And this one is more clear about why we're not indenting the first line, I think. Because because I was using it in this mode. I think the reason for that is if this body ends up being empty, you'll have struct brace and then a new line and then an end brace. And that can actually go inside of that, right? No. It's just as it is. So, okay, let's move on. Parse element. I think I remember what parse element does. It does something like this. So it's really easier to show on one line. Something like this. Oh, this is the thing we're parsing. And we expect to get that. I think if we start at 0, 1, 2, 3, 4, 5, 6, 7, 8. And end is, we'll put something after. If we go all the way to the end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 34. It's supposed to find the next delimited thing, but I'm not sure if that's what it does. So we'll test it and see. No. Okay. So I don't remember what parse element does. Let's look and see what it does. Oh boy. It's one of these guys. Okay, it continues until it reaches the end, but it skips stuff. Does it return early? No. It'll leave the while loop though. If you reach the end. If you reach the end and or the level goes to 0. Oh, level goes to 0, right? So if you hit a delimiter. So if you were at 9, you're already into that string and you hit a delimiter again. No? It's okay. I thought it would stop there. Maybe it's not that it handles double quotes, but it's more like it handles these kinds of things. Huh. I guess it's inclusive. Okay, I actually didn't expect that. Really? Is that what it's supposed to do? Okay. And the idea is that if you had something nested, like something like this, I added 3 characters, right? So I need to bump that to 3. And it's just so I don't have to make sure the count is the same. Let me make that a string. So then I can just say line, and here I can say line length. So the idea there is that if we tell it we're here, we want to parse until the end of that we just began an element or a delimited body, and it's going to go until it reaches here. We don't want it to stop here because this is an inner level. I believe that's what this is supposed to do. Only I forgot to update this thing. The point being that it stops here and doesn't parse that rest of it out. Yep. So that's what parse elements for. And I think I used that in another project where I, again, same kind of thing that indent was used for, except for parsing some kind of hierarchical structure written out as a string. This helps us just grab the current element we're in and not anything after. So what does escape do? Oh, I'm not going to cheat. I'm going to try to guess from the header. Escape a string with an escape character and characters to escape. Okay, that's pretty straightforward. So if we add a line, something like hello world, and we wanted to escape both the comma and the exclamation point, we would expect hello, comma, world, like something like that. If we, oh, I should indent these, shouldn't I? Escape the line with the escape character. Oh, let's make it a little bit nicer. We'll escape with a hat. And then we're going to escape. It wants a set. So standard set characters. Can we, what are the constructors of set? Can we pass individual values? Okay, we can pass ranges. Iterator, again, ranges. Okay, I guess we'll have, oh no, it took an initializer list. I saw that. So I think we can do this. Yeah, we can, I think. No, we can't. Oh, yeah, you're right. Initializer list got to be like this, right? Yeah, thanks, not seeing. I think that was it. Okay, let me break that, because I want to see it break first. Yeah, so that's exactly what escape does. So it's a generic string utility that escapes things. So unescape, I think, is the opposite. Oh, I already had space for it. So unescape, we just turn things around. Okay, escape doesn't need the characters to escape. Yeah, that makes sense. One thing I'm wondering about, does it escape itself? So if I have something like that, will it do that? Actually, no. What did it do? It left it in there. I guess you have to actually have the escape thing in the set too. That's kind of dumb. Why did I do that? The escape character should automatically be a character to escape. I can omit the set part. Let's see. Is that smart? Oh, you're right. See, I'm always learning stuff about C++, even though I've been doing it for years. I guess I kind of assumed it needed to know the type there, but it's inferring the type for me, which is cool. Yeah, I'll leave that in there just to point out that right now it needs to be in the set. And if I change the requirement, it would be to do that, and then I would change the code. So we'll leave that like it is. This should do the same thing, though. That shouldn't need to be told. Right. Yeah, I think you started on C++11. That you have an advantage over me in a bit, I think, because I was used to C++, the old C++ for a long time, and C++11 I started picking up 2 years ago. All right. Split is the last one before I take a bit of a break. Split. Ooh, sorry about that. Got a text and it was on full volume. All right. So split returns a vector. So here's a case where the inference doesn't work because some reason with Google test and this might have been why I had been putting the type there explicitly, because you have to do it in asserts in Google test for some weird reason. So if I split the line being something like that, let's split on space. I expect hello, comma, and world. See, it doesn't like it, so I wonder if I put it second, will it figure it out? No, it still doesn't like it. For whatever reason, it needs me to do 2 things, actually. Or maybe it's just this parentheses, now that I think about it. No, see, it's not happy with that, or that, I bet. It needs me to do 2 things. Put it in parentheses, and I have to say standard vector strings. See, now it's happy. And even if I just remove those parentheses, it doesn't like it, right? And it's not just IntelliSense. If I try to compile it, it gets really whacked out, unless I put those parentheses in there. I think it has something to do with macros. Macros are evil. Okay, I don't like it when my tests pass right away. I want to see them fail first, just as a sanity check. All right. So that's exactly what split does. This is our simpler version of split. We made a more advanced version of split that took a strategy function object and all a few streams back. And this is a simpler split. And that's it for string extensions for now. Good. So I'm happy. I have now at least test cases for every function, and I'll need to go back and write the comments for these. Why don't you do a assert NQ? Or do you mean NE, or is there an NQ? You can try. So what, like, try to do what I wanted? Any? Yeah, well, I should look up in the Google test manual to see what my options are. Maybe there are other, I know they're like assert string. For if it was a string, that they have an assert string case equal, case not equal, string equal, string not equal. Instead of doing the sanity check. Oh. Yeah, you mean like that? Then I'll see it break, right? But break more than that it expected them to not be equal. I mean, that works too. I hope I am understanding your suggestion. Just different ways to make sure that the test isn't passing for the wrong reason. Oh, I see. So just it'll always fail at first. And I can see which one fails. That's a good idea. Something like this, you're saying, right? That'll fail either way. And we can just see what line it failed on and then say, okay, yeah, that was the invalid alternative. Yeah. So I'm just doing a time check real quick. So it's been a little bit over 2 hours. I'm going to take a break, but probably come back after getting something to eat. So a lot of streamers will keep their stream going, saying they'll be right back. But I don't have a nifty be right back or lunch counter or anything like that. So it'll look like the stream is going offline, but I'll be coming back in like, I don't know, half an hour or something. So before I do that, let me check in the code and then I'll do a little run through about what we did. Oh, have a good night, Nazi. Be back in half an hour or so. And you're welcome. I build RS. Are you really building RS? And what is RS? Let's see. Establish tests for the rest of string extensions. Oh, RuneScape. Is that a reference to, was it Kit Boga? He's into playing RuneScape on chill streams now? Or is RuneScape a meme that I haven't been keeping up with? I know RuneScape has been around for a long time, but I hadn't heard mention of it until recently when I saw Kit was playing it. Okay, I'm just gonna make sure I checked in everything. So it's just a coincidence then you play RuneScape. That's cool. Okay, stuff at the root I did not check in. Oh, it's just a license file, and I didn't push my last change upstream. You have one more question, but you ask later when I'm back? Okay, cool. Yeah, lunch is soon. Not quite ready, but it's being picked up, and then I'll come back after that. So let me just do a quick run through for anyone who might have been coming in late. Going back to my notebook. So at the beginning of the stream for, I don't know, about a half an hour to an hour, I finished up a component that dealt with UTF-8, which is Unicode encoding for international character sets. I took some test vectors that I had found previously that I found really useful for understanding what to check for. And I wrote some test cases to catch these ones, which I hadn't covered. And I realized I had already written code to cover these. So we covered the ones I didn't think of. Then we fixed the code to match our tests. And then that basically was the end of the UTF-8 component. It's all nice and working, encoding and decoding. So then I moved on to system abstractions, and we updated the directory structure of that component. And I started establishing unit tests. It's going to take a while. I don't know if I'll do it all now. Maybe just do some of it and leave the rest for another time. Just because looking at legacy code too long, it can get a bit of a drag because it's not new stuff. It's just testing old stuff. So we'll see. There are a couple streamers I need to check out that viewer suggested that are into system level programming, which might be cool. And I wanted to do a show and tell of a tool I made earlier, just because a viewer mentioned writing another language in C++. So I actually have a tool that has its own, what they call domain language or domain specific language. Can't remember the term, but a language that it uses to describe how it works. Describe basically like how to script it. And I want to show that off. And I have a note to add something to my pattern list. So after the stream, I'll take a lunch break and get in some retrospective of how the stream went, and then I'll set up the plan for the next stream, which will probably be just a little bit more of system abstractions and probably show off this tool. And I'll think about if I want to do some actual new code or just focus on this component and get it all finished up. So we'll see. So that'll be in like half an hour to an hour. I'm not quite sure. And I'll probably stream for another couple hours. That'll be, what, 5 p.m. to 7 Pacific. So I'll see you guys in a little bit. Thanks for watching.